Now it's time to work on the game and actually use what we want to use. So we want to have, what was that? The W key here. W key, fix those errors. And the S key, like those. Let's double check if the game still runs. So we basically added a bunch of stuff, but we are not using that yet, right? Now it's time to use the 2 textures that I supplied in the repository. We have a Pong from scratch logo and a button. And if you remember, we need to implement those in the assets.h and cpp file. We need to add new asset types. We have an asset sprite button. I like to add the dimensions. It is 64 by 16. And then we have the asset sprite Pong from scratch logo. Those 2 need to be implemented in assets.cpp as well. So change to that. We need to know the texture size of those. It's just like a pedal for the button. Actually, the button is something different. The button is 64. And if we scale that by 3, it's going to be 240. But since we have 3 pictures of the button, let me show you what that means. If I were to export this, it draws 3 pictures. And so it is 3 times 240. So it's not 240, but 660. But if I remember, I put those pedals to 50 and 100. Let me try changing this. That's 16 times 3 would be 48. All of this, that would be 48 too. And this is 48. And then the pedal height. Pedal height was 32. 32 times 3 is 96. And now we are looking at something much better. Then we can use 48 here times 3. Scaled by 3x, and then we can move this comment out here and have a more consistent thing. That would be 660. That's great. We also need to break here and fill in the other comment. For the background image, I don't remember the size. It is 300 by 200. So 300 times 3 would be 900 and 200 would be 600. And for the button, it has a sub width and height. Sorry about that. That's actually 64 times 3. 64 times 3 for the button is 192. And then that would be 48. .f. And then the final size would be times 3 again. That is 576. .of. And that's 900 by 600. Don't forget the semicolon. We put that here as well. Good. So put these into the function of get texture, where we calculate the size, and then we need to change the get asset function. And I did a little improvement here. I assigned the size outside, and then we don't need to assign that in every single one of those case blocks. Then we just have the return data. Okay, and for the, let's see, we have the asset Pong from scratch logo. Let's keep this in order though. Let's put the asset sprite button first. That button reads in the, not the font atlas, but the tall button underscore 64 underscore 16. And the logo reads in the Pong from scratch logo, like that. Don't make a mistake here. And I think that is it. Okay, put the size and get asset at the very top. Okay, now we get the asset data and the texture size. Let's double check how this looks. Okay, didn't change much, which is good. Should not have changed much anyways. Okay, now we switch to the game.cpp file, and at the very top, before the game state, we create an enum. We want to be able to switch between game modes. We want to be in the menu, and then we want to be in the game. And so I call it game state ID. I keep track of some sort of game state ID, and I have the game state main menu and the game state running level. Those 2 game states need to be stored in the game state. So we have a game state ID, game state, and that can be a bit confusing, game state.gamestate, but you'll get used to it. You can also change it to game state ID if you want. Now in the update game function, we go into that. When we are in switch game state game state case. Let's say we are in game state main menu. We want to do something else than if we are in game state running level. We already know what we want to do in running level, which is all of this code. And I would like to create an additional function, an internal function, internal void update level. And this update level just takes in the entire contents of this, and we supply the stuff we need. We need the game state, pointer, the game state. We need a UI state, UI. And it looks like we need input state. I think I want to put the input in front of the UI. And of course a delta time, yeah, float dt. Now we successfully extracted that, and we can just do update level game state input UI and dt. And to be honest, I don't like the ordering of UI and input. Not sure why I did that, but I think I want to put input after game state and then the UI state UI after that. So change those around. And we'll probably have to change those around in the platform layer as well. So change back to the platform layer where we call update game and switch these around. Yep, we need to do that. So instead of UI, first we use input and then the address of UI. Now in the game, when we are in the menu, we want to do two things. We want to do a button and we want to do another button. Like the first button will do nothing. And the second button will be the button that we click on. And so first, I want to just do a do button call with UI and input. That would be the asset, write Pong from scratch logo. And let's define an ID here 1, but we'll change that in a second. And that rectangle would just be the entire screen size. And the position will be 0.0f and 0.0f. And there's not going to be any text. That's what I want to do in the main menu state. And when we start the game, we should be in the main menu state. Oh, because by default, the do button, of course, is not implemented in UI.h. So we need to go back to do button in UI.cpp, copy the entire line, go to UI.h, and let's put this below do text, add the do button call, and set the text parameter to default by doing text equals 0. Now we expose that to the game, and we actually know about it here as well. And then there's no more error. Let's try building. It shouldn't do much. It shouldn't actually draw anything. When we create a new UI element, we need to check if we got one. Then we can do all of this stuff. We can do all the stuff, even the label only. So it can be that we have reached the maximum amount of UI elements, which would be an else case. X assert 0 reached maximum amount of UI elements. And so what I would like to do is extract this into a function and then call create UI element, applying the UI asset type ID, the ID, the rect, and the text. And that is going to be another internal function. So we put this at the very top. And let's actually put this below the get text with. There's going to be an internal. Let's center this first though. Internal UI element pointer create UI element. And then we supply the UI state pointer UI, the asset type ID, the uint 32t ID, the rectangle, and the char pointer text. I think we can also break that up. And then we do UI element pointer e is 0. And below here, we return. That makes it a bit more safe. And then we don't worry about, oh, do we have a null pointer or not? Now we get the correct error message, which is reach the maximum amount of UI elements. That's correct. Because we forgot in update UI to actually reduce the UI element count back to 0 every frame. And so we're just accumulating a bunch of them. Okay, it's not showing up. It's just drawing these entities because I create them and it's supposed to draw them, but it's not drawing the actual UI element. And this is where we need to go into the VK renderer. And so in here, in the VK render function, I did a few improvements to make this a lot more easy to do. Like currently we need to get some sort of material index and we store the materials in the game state and every single entity has a material index and it doesn't really make much sense. And so what we are doing now, we are making the renderer simpler to use. And so the first thing that I wanted to do is to create a new const expression, or actually go into the game at the very top and remove the max materials and move them to the renderer. And then also from the game, inside the game state, we take the material count here, extract that out and put that into the Vulkan context. We are going to manage materials in the renderer because these materials are simply just colors. And then instead of having a material, which is some weird thing, we just have material data. If you remember, material data is inside shared render types. Shared render types are the render types that are being sent to the GPU. And currently there's only color. If we want to use them in the renderer, we need to include the shared render types here so that IntelliSense works. And inside the game, we no longer need the shared render types. We don't need to know anything about rendering. The game should not have to worry about this. And then further down in game.cpp, the only function we need is the create material and get material functions. I guess we can extract all of them and then merge them into one. And then we supply those to the renderer. We go back in here and right below the VK context, we paste them in. And I thought about a cool idea. We just have one single function that is called get or create material edx, because this is the only thing that we need on the GPU, the material index, because we are going to copy an array of materials to the GPU and index into that for color. And so that's the only thing we need to get, and that is not something that the user should have to worry about when they write something in a game. And so a material, since it's only color, is now disconnected from the asset ID because it doesn't care it's just color. And the get or create material index just goes through all the materials in the VK context. And then it just checks, well, if, remove that, VK context, materials on I.color is the same as the supplied color. And I think we need to spell VK context correctly for that to work. We don't need to get any material here. And then we set the material index to the index I. And that should be VK context. Oh yeah, and then instead of, let me center this a bit. Instead of the game state, we supply the VK context pointer, VK context, to this function. So the top part is searching for an existing material. If it doesn't exist, we just set the material index to the VK context material count. And then we set the VK context materials on VK context material count ++ dot color to the color, but only if the VK context material count is less than max materials. But then if that is not the case, then we just return, I would say we return 0 here. We don't use an invalid index, but 0, because we'll always have one texture. Okay, so this is the only function. And since we copied all the other functions, just delete them. We don't need them anymore. I just want to have the get or create material index. These other functions are no longer needed. And then obviously this is gonna cause a lot of bugs down there. We no longer have a get material, and a descriptor just takes in the asset ID, which is something that we don't have. And so in the game.cpp, we now need to change our entities to have an asset ID instead of a material index. And so now we can just look at entities and see, oh, they have this color and this sprite. I think this is way more flexible than the system we had before, which was very rigid. And you couldn't really read the data very well. So yeah, we do an asset type ID on the entity, and a vec2 or vec4 color. We add those two in here. And then of course the struct material is no longer needed. Delete that. And then down here, when we create an entity, we also need to set the asset type ID to the asset type ID that we have not supplied yet. And then the E color to the color that we have not supplied yet as well. And I thought about the following. We just put them at the very end. We do asset type ID. Asset type ID is bright white, and vec4 color is the default color of white. 1.05 everywhere. Since we changed the interface to create entities, we also no longer need to get materials here and can just say, well, when we create an entity, I want to have an asset sprite puddle and remove that. And then we just repeat that for the other puddle. Asset sprite pedal and the asset sprite ball. We can further improve this, but we're going to do that later. We can further improve this, like the get texture size. We can implicitly do this, but for now that's fine. So the game should be okay now. Now we need to fix the renderer. So go back into the VK renderer, into the VK render function where we do the entity rendering. The first thing we should do is clean up the transform. What do we need in the transform? We need the asset ID. We no longer need a material index. We can get that ourselves. And we need a vec4 color. The position is still something we need, and the animation index as well. And then I noticed another problem. If we have too many transforms, we have the same problem as with the UI elements. So we need to do a check here. If VK context transform count is less than max transforms, then we can only do all of this. Otherwise, we need to inform ourselves about it. Else we need to do an, let's put this in the center, cakes, assert, 0 reached, maximum amount of transforms. Put an exclamation mark here as well. And now the only thing left to do is get the material index. And for that, we just do uint 32t. Material index is get or create material index, takes in the VK context, the color, and it will give us a material index. And we don't have to worry about anything like that on the gaming side. And I just noticed, since this is a Vulkan thing, I like to call this VK get material, get or create material index. Technically, it doesn't have to do with Vulkan, but I'm doing it anyways. So yeah, now we add a transform, and the thing we need to add is the context, the asset type ID, the position and the color, and the animation index. Let me fix the text later. Okay, so down here, we don't need that material index anymore. We need the E asset type ID. We need the color, the E color, and then the origin plus sprite offset, I will say. Seems like. Now for UI rendering, let me see here. We no longer need to do that. We can do this through render text. Render text should no longer take in a material index. About the render command, I have to think. And then in render text, the material index is useless because all we need to do is, and so we can now supply a vec4 color to this function and change the text color if we want to. Let's break that up into a new line. It's a bit big. Actually, we don't need to do that at all. We don't even need to do this. We just supply the color here plus the origin and the animation index. And we're golden. Okay, now back to UI rendering. This should all be fine here. The label count should be okay. We still have a little bit of problems with the material count in the game stage. I don't know what I did back then, but delete all of this and copy data to buffers. It's a little bit further down than UI rendering. The scope. Delete this. All we need to do is we copy the VK context materials to, I suppose that's need to be an address. Const void data. Don't think that's correct. Yeah. This is also not correct. That should be like this. And we have the size of material data times the VK context material count. And then of course the VK context material count will be set to 0 afterwards. So we reset the state every frame. Okay, I just missed something. The asset type ID, the descriptor we get is from the entity we draw. And then we add the transform. And if that works, probably not. It never works the first try. I found the bug. Setting the material index is a problem, or removing it, because an index can be valid if it's index 0. So if the material index in the vk get or create material index function is still an invalid index and we have materials to create, and I think I'm gonna break this up into 2 ifs to make this easier. Basically, I wanna put that if in here. Say if it's an invalid index and we have something that we can create, we create something. Otherwise, we do a cakes search 0 and say, well, reached maximum amount of materials, exclamation mark. And I think I accidentally did not close a function. I think it is that. Accidentally removed a brace here. Make sure you have the closing brace to this function. I somehow deleted that. Let's try that real quick. Okay, that works. So we are still not drawing the UI element, of course, because we are not doing that in the VK render function. So we now go back to VK render where we have UI rendering. Above the UI label count, we can do a for loop un32t UI leedx, set that to 0 and do UI leedx less than UI element count and UI leedx plus plus. We do a for loop over all the UI elements. We get the UI element e as the UI elements on UI leedx, and then we basically do the same thing. We get a descriptor from the e asset type ID. We check if we have that. We basically do the same thing here. We check if we have that descriptor. Then we create a render command from that descriptor. If we get a render command, we set the RC. We basically do the same thing as with the entity. So let's copy that here. We do the RC instance count. We set that to 1 instance, and then we draw the transform. We add that here, which is asset type ID, color. Don't think we have that yet on them. And then the origin would be e rect the position, and then the color. For now, I supply 1.0f, 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 1.0f. And if you want, at this point, you can supply your color to your UI elements and, extend that in a way. Boom. Now we draw the UI elements as well. And it's drawing Pong from scratch. Yeah, pretty small. Okay, I thought about how we can change the problem that I encountered with the size not being correct. I could just supply a vector2 size, which is default 0. And then we can define a size our own of the rectangle. If we supply that, the render will use it. If not, we don't. We could create a un32t subsize x, which would be texture.subsize, and a subsize y, which is a texture subsize y. And then we just check, if we have size.x and size.y, then we set the subsize x to size.x and the subsize y to size.y. And now instead of using the texture subsize here, we just use the subsize x and subsize y. Now when we go back to the vk render function in the UI rendering, we can supply the position, the animation index. We also forgot about that, the e animation index, and then the e.rect.size. Also, not all control paths return a value is something that I get as an error. vk get or create material index. Let's see here. In get or create material index, make sure that the return material index is outside this if check. I accidentally put that in here. Okay, I found out what I did wrong. I need to put these in top here. I need to do the calculation first. We need to calculate the UV width and height. And then if we have a size that we want to use to scale our image, we then apply the scaling. Okay, now it finally works. We have Pong from scratch. Great. As an image in front. And now in game.cpp, and if check against that, do button. Takes in the UI input, an asset type that would be the sprite UI or sprite button, 64 by 16, takes the ID to a rectangle, and that rectangle is going to be 400 by 400 down, just fixed positions. And the size, I don't want to supply the size. I want the size to be implicitly created. And so I just don't fill out the last 2 points here. And the text is going to be play. And if we press that play button, we set the game state to game state running level. And then I also thought about another button that we could do. UI input asset sprite button. That's going to be ID 3, which is another one at x400, 470 seem to be fine. We don't supply a size, and that is going to be quit. And if we do that button, we set the game state to no longer running, or we try to quit the application. And right now we don't have an option to do that. I thought about how we could do this, which is a function called platform exit application. We need to implement that function real quick. Change to platform.h, create a void, platform exit application. And all we do in win32 platform.cpp at the very bottom, we paste that and we set the running global variable to false. That's all we need to do. And that's why I wanted to include this, because it's very simple to implement. And now we can quit and play through button. Also, I don't know if it actually works. We'll have to check. Paste this in here and try to build. Yes, it does work, but the getTextWith function is not working correctly yet. The IDs are not working correctly either. And this is because we do not have layers set up properly. So we want to do a button with the background using ID 1. Then I want to do a UI global layer ++. We are drawing these buttons on top, and we also want to decrease that layer. I found out the problem. We are not supplying a size, and therefore it's looking at the rectangle here. We need to supply a proper size. The proper size of these was 196 .f and 48 .f. And then this is going to be 196 .f and 48 .f. You might notice this is getting quite annoying to do. And so we need to find a better system in the future. There are many ways to do this. There's also the question of world and screen size. Usually the world size would be operating in the 64 by 16. And then we will try to scale this in multiples of 1 to the screen. All of these things we're going to have to touch one by one. For now, this is going to be okay. And let's double check if this fixes the hot thing. Oh, it actually also places those properly now, which is great. But it's still not setting them to hot. I forgot one thing. In update UI, of course, we need to do UI hot last frame is UI hot this frame. We never set last frame's UI, and therefore it never happens. And it's never being set to hot. Yeah, it is better. It's not setting that back to... Oh yeah, of course. It's not setting that back to inactive, because in do button, when we release the mouse, we also need to set inactive on the UI. It's very explicit calling. I forgot the set inactive call. Now it should work as intended. Yep. And so play will go into the play mode. And if we start it again, quit will quit the application. Great, so now we have an interactive UI that we can model to our heart's content. We can do basically anything we want with this UI. And we can use these do button calls to basically do anything imaginable when it comes to UI elements, like dragging and dropping and all of these things. There's just one last thing that I want to implement in the game.cpp file, and that's this ID. You can basically do a counter if you want, but what I would like to do is create a line ID that I have stolen from someone, which is a very cool macro. You just define line ID, you take in an X, and then you cast that to a size T and use the following line, which is the line of the file you're using this macro in. You bit shift the line up by 16 bits to generate a very large number, and then you OR together the value, which can basically anything. Usually I just do line ID 1. And so yeah, we can now do line ID, and usually that's what I do in my engine. I just call line ID a bunch and supply that to these functions. Now double check if that still works. Should still work though, doesn't change much. They should all be unique. Okay, does still work. Okay, now this is all I wanted to show you. I hope you liked this tutorial. If you did, leave a like. If you like what I do, consider tuning into my Twitch. I stream at 10 a.m. Central Eastern Time, which is 1 a.m. Pacific Daytime. If you want to directly support me, you can do so via Patreon. This will give me more time to work on my game Cakes to the, and you will get reading access to the GitHub repository. Patreons will also be called out at the end of every video. Subscribing and leaving a like also helps a lot. Thank you very much for your support. So yeah, thank you to Michael Phillips, Felix F, and Meo the writer for your support. Additionally, pixel art I publish on itch.io will also be available for Patreons. We'll now do the Git stuff. So yeah, next time I will probably finish the Pong game, and then we'll see what we do with the engine that we have. We might do some improvements. Like we still allocate on the heap and stuff. We can do the allocator. So yeah, I'm gonna do the Git stuff now. Git add, git checkout -b. That would be 15 finish Pong. Git commit, one is m. Added UI to the framework, because it's actually a framework. And then we do git push -u origin 15 finish Pong. Yep, and this is where we start next time. Thank you all for watching.